My name is Mehmet Kaan Acar.
And my name is Talha.
This is our EE414 VLSI design term group project, and we have implemented 32 bits of RAM with 8 words, and we have also implemented this decoder for accessing memory elements. And this is the decoder schematic. We have sized it accordingly for our SRAMs, and sizings can be seen here. The word lines topology are the same as this one, and this schematic can be seen here. It is rather long, but it has 3 inputs and outputs 8 words different, so that we can access the row that we want. And we have also implemented this layout. It has a quite bit of delay, but it still works. The delays are approximately 1.3 nanoseconds for accessing the word lines.
For the type B cells, the schematic is pretty much the same, but except for the fact that we have a sensing circuitry in this case, which is the sense amplifier, and except that we have worked hierarchically in the 1B cells, the 1-bit SRAM's schematic is pretty much the same. So 32-bit array is just made by just cascading all of them. This is a test bench of the top level schematic. These are the components that were used, as I said. So we used the 2x4 clock row decoder for the 1B cells and the 3x8 decoder. So these, as I explained, were used. So for the bit line referencing circuit, this is the topology that was used. And for the read-write circuit, we used the sense amplifier and the write-enable circuitry. And finally, I will explain how the read operation takes place in the 1B cell. And these are the plots that show the reading SRAM array cell when QB is equal to 0. Then we move on to the write operation of the 32-bit SRAM array. These are the parameters that were set. And this is the writing 0 operation on the net queue when the selected SRAM array cell is selected. Finally, we move on to the power usage of the 1B cell, which happens to be 295 microwatts at 5 volts at 500 megahertz of frequency. So we move on to the layout, and finally we move on to the DRC and LVS are checked correctly. And finally, for the minimum voltage, in this case it was 1.2 volts, and these are the final results. At 1.2 volts, we can see that the SRAM does not lose its functionality, and the power consumption turns out to be 1.61 microwatts, and this is at 300 megahertz.
So we have also implemented another SRAM design by changing its cells, and it uses 60 type 4 SRAM layout, and it is thinner than the type B, the other one, and we have also implemented the same features except for the sense circuitry. And the sizings are not the same, as we have sized all of the transistors on this cell the same, 1.4 micrometers. And this is the part of the layout.